Good morning. Good morning, and welcome again to this lecture of electronics. And I guess we were studying the combinational logic circuits. We have almost completed half adder, full adder in our last chapters, and today we are going to continue with the same pattern. Let me introduce myself. Myself, Dr. N.D. Meshram, Head and Associate Professor, Department of Electronics, Sri Mathuradas Mohta College of Science. And yeah, yes, this is what we have started, and I guess my screen is visible to you all. So we have almost completed multiplexer, and we have studied in or there the 4 is to 1 mux, right, in the last lecture. So this was the circuit of 4 is to 1 mux. Multiplexer means many inputs to one output, right? So many inputs can be connected to a single output. That is actually a switch, right? So we can switch according to the select lines. This is what we have studied in the last class. And yes, of course, we have also studied about the 8 is to 1 mux, in which we are expected to use 8 AND gates and 3 select lines. So 3 select lines were supposed to give you 8 codes, and according to those 8 codes, we were able to select one of the input D0, D1, D2 up to D7. Right. So this is the circuit for 8 is to 1 mux. And what is the need of multiplexing? So when the information is to be received from many sources over a long distance, right? So it would be difficult and expensive to connect each input data line from the source to destination by connecting separate lines. So I guess agar main if I say ki I have an instrumentation system in which I need to connect say many say inputs, right? Like say biomedical instrumentation in which I require pressure, blood pressure, temperature, oximeter, and all the varieties of say the details or the data that I need. So I have to attach it to 8 or say 9 separate lines. So instead of using that, we can use at a single line, and the data can be transferred each bit. So we can select accordingly, and we can send the data as per the requirement. So this is very useful in that. The other one is supposed to be an expensive one. So we say generally use this multiplexer circuit. So this is the one need or one application of multiplexer. Then at the transmitter side, connecting a suitable multiplexer, only a single line can be connected over a long distance from the output of a mux to the receiver. Now you know that we have landline phones, right? So these landline phones were used to connect many inputs into a particular say point, and they are being transferred to a larger distance, say up to Birdie. So if you need to connect all those lines which are connected to Jeripatka, so it will be very cumbersome and expensive, right? So what we do, we connect all those lines particularly, and we select one line to transfer from say Jeripatka to Birdie. So this is the advantage, and this is very less expensive as compared to the many inputs, right? So this is another advantage or application. Then multiplexer also can be used to use common device for number of identical inputs. So that is another use of that. Uh, Common device can be used. So a single device can be used for say multiple purpose. So that can be also one of the application. And it not only reduces the connections but also saves the circuit size, PCB size, propagation delay, and cost of the circuit. So these are all advantages of using multiplexer, right? There is one example. If you need to connect this, I guess this is not your in your syllabus. Now this is again there is one more which has to be connected. So I have a 2 is to 1 multiplexer, and I have to make it 4 is to 1 mux. So how you are going to connect it? So this is that connection diagram. Now in every 2 is to 1 mux, we have a enable signal, right? So we use that enable code for these two. So we use 2 is to 1 mux, and we have 4 inputs, right? So how we are going to convert this? So this is 2 is to 1 mux, which is having D0 and D1. So and the lower one is D0 and D1 again. So we can connect it to D0, D1, and S0 is supposed to be the single select line which can be used for 0 and 1 for 2 is to 1 mux. right? Now we can connect the enable terminal, that is G over here, which can be connected in two forms, and we can call it as a select line one, right? So one is directly given and the other one is inverted and given to the first 2:1 mark. So we can convert this 2:1, we can make a 4:1 marks by using 2:1 marks. This is a very important question, and this is how we can implement different types of multiplexer circuits. And the output of all the both the 2:1 marks can be ordered together and we'll have a single output. So this is 4:1. So by using 2:1 marks, we can say implement, or we can develop a circuit of 4:1 marks, right? So, and this is the select lines that we are having. S1 and S0 should be there. So it is S1 and S0, and the output is D0, D1, D2, and D3. Now, I guess this much is understood. Do you have any questions on this? Anyone? Hello? Have you got it? Shall we continue?
Yes,
Hello,
sir.
am I audible?
Yes, sir.
Yes, sir.
समझा है ना? So this is multiplexer, and the opposite of that is called as demultiplexer. Now in multiplexer, what we have done, we have many inputs and one single output. Now the opposite of it is demux, means we have a single input and we have many outputs. So at the receiving end, what we do is we have to convert back this single line to many lines, right? So the same circuit, almost the same circuit, can be used as a demultiplexer circuit. Just a difference that we are not using the OR gate at the output, right? So we are using AND gates. We have select lines similarly, but we are not using OR gate, and similarly we don't require n number of inputs, so a single input is fed to all the AND gates, right? So the input is supposed to come at this point and to the many inputs, right? So this can be selected by using the select line. Similarly, as good as we have done it in, say, multiplexer circuit, the same situation is being used. Now, say instead of using a OR gate over here, we are using all the outputs over, right? So D is the data line which is connected to all the AND gates, and we are having select lines S0 and S1, which is again being connected as we have connected it in the multiplexer circuit. And depending on the codes which have been generated by S0 and S1, one of the gate is one of the AND gate is supposed to be enabled, and the output is fed through that AND gate, and it is taken at these four outputs: Y0, Y1, Y2, and Y3. Okay, so this is the circuit for demultiplexer circuit. We call it as demux, and now this is 1:4 mux, 1:4 demux, right? So we have one input and we have four outputs. So that is why it is called as 1:4, right? So in transmitting end, we require mux, many inputs to single line, and at the receiving end, means at, say, birdie, where we need to connect it, we can use this demux circuit. So earlier it was being used, and this is how it is going to give you the output. The select line shows 0, 0, 0, 1, 1, 0, 1, 1, and according to this codes, almost one of the output, the data is fed in on one of the outputs. So Y0, Y1, Y2, and Y3. So these are the equations over there. Y0 equal to S1 dot S0 D. Y0, Y1 is equal to S1 dot S0 into D. Okay, now we'll have to put bar over here. I guess it has been missing. So it should be like Y0 equal to S1 bar S0 bar into D. Sorry. Similarly, Y1 will be equal to S1 bar S0 into D, and Y2 will be equal to S1 dot S0 bar D, and lastly Y3 will be equal to S1 dot S0 dot D, right? So this is the equations for, and we require to, we need to put bar on this size, right? So it will be Y0 equal to S1 bar dot S0 bar dot D. Similarly, Y1 will be equal to S1 bar S0 D dot D, and Y2 will be equal to S1 dot S0 bar into D. Similarly, Y3 will be equal to S1 dot S0 dot D, right? So this is the multiplexer circuit, and this is the truth table of the multiplexer circuit that we are having over. So this is the equation, and these are different ICs of the multiplexer ICs, which are being available in the market. So 74138, that is 3 to 8 line decoder, 1:8 multiplexer, that is inverted input we are having, and these are the other ICs that can be purchased from the market. Now, the applications of demultiplexer circuit, demultiplexer can be used to route input to specific output decided by the control word known as data multiplexing. So we can we can arrange the data, or we can give the data to say specific input, specific output. Now, similarly, it can be used for clock demultiplexing. The clock input can be connected to the required digital circuit like counters, registers, instead of using a separate clock for each counter circuit. Now, I told you what is a clock circuit. So we require in digital circuits, we require the clocks should work in unison with the crystal oscillator. So one clock can give the clock pulses to all the circuits. So for that, we can have a single clock and we can demultiplex it, and then it is being served to all the other, say, blocks of the microprocessor or a microcontroller, so that they can work in unison. So this is the advantage application of demultiplexer. Now, demultiplexer plays an important role in memory addressing by means of its decoder application. Yes, of course. Now, we require to store the data in memories, right? So we can address them by using this demultiplexer. So we have to decode accordingly, and we have to feed the data or store the data in the memories likewise. So demultiplexer plays a very important role as far as say decoder application or for the storage of the data in the memory is concerned. And also it can be used for switch encoding, right? So that those are encoders which can be used for different purposes. So these are the applications of demultiplexer. Is it understood? Do you have any issues on this? If you have any problems, you can ask begin. Okay, so the next topic of this unit is the decoder and encoder circuits. We'll try to do that too in this lecture. So encoders, what are encoders, right? And what are the types of encoders? Now, encoders means to convert a particular thing into codes, right? A particular data into codes, that is called as the encoders. And to decode that, we require decoders, right? So first, what we'll do, we'll code it. So in defense, if you have to maintain the secrecy of a data that is being transferred from one point to the other, what we do, we say connect it, or we convert it to say coding, right? So that language is in coded form, so that the say I mean, so that the enemies would not be able to understand that language. So what we need to do is we have to encode that particular data, right? And for that we require the encoder circuits. Now, similarly, when we when we get this data or receive this data, they should be decoded so that we can get the original signal, so that we are able to understand what we are supposed to do, right, in the receiving end. So for that we require both types of encoders and decoders, right? So encoders are actually uh, digital circuits which is having, say, like calculators, which is having input numbers from 0 to 9 expressed as common inputs, but the calculator is a digital circuit and it accepts only binary codes in order to process the data, right? So what we do, we have numbers, so we need to convert the 0 to 9 in binary codes. We know what is number system, and we have almost completed that portion of selecting, say, converting those decimal numbers into binary, right? So 0 is coded as 000, and 9 is coded as 1001, right? So these are the coding of, say, the decimal numbers into, say, binary system. So as in calculators, when we press one key of, say, one number, right, so it generates a equivalent code in binary of that particular number. So that particular circuit or the circuit which is going to convert that number into a particular binary code is called as the encoder, right? So internally, it uses an encoder circuit to convert this decimal number into binary code to understand the machine that which number is pressed, right? And the next number is also converted into its binary code, and these two numbers are being processed. So this is the main concept of say the encoder to convert it into different lines, right? So we are having on that note, we are having different types of encoders. First one is the BCD encoder. BCD encoder means binary coded up to decimal, right? So which can binary numbers which are being coded up to a decimal number. Decimal number means we start from say 0 to 9. So these are only the binary decimal numbers, and we need to convert into say a 4-bit binary, right? So how we are going to convert? The positive high is taken as plus 5, whereas 0 is taken as ground. So if I need if a switch is pressed with a number say 3, then the code could be ABCD will be the 4 bits, 4 lines on which the codes are supposed to be generated. So we'll be having 0011. So 11 is the binary of decimal number 3, if you recall what we have studied in the number system, right? So this is how it is being encoded, and this is the basic circuit of that encoder. So when we you see this, we have different lines, right? Likewise, and we are using OR gates, and accordingly we have tried to generate the ABCD. So this is the LSB and this is MSB. LSB means least significant bit, whereas MSB means the most significant bit. So A is supposed to be the most significant bit, whereas D is the less significant bit. When we press this key 0, so all the outputs are supposed to give you 0 because it is not being connected to anything, right? When we connect 1, so what only D should remain at 1, the others A, B, C will remain at 0. So we have not connected it to any terminal when it is being pressed. Now this only this input will be high. So the output of this D output of this fourth OR gate, D is supposed to become high, right? Similarly, it is going to generate that one key is being pressed. For the key 2, the 2 key, this is push to on key. When it is being pushed, then it is being connected to this line, and this is a positive line. If I'm not wrong, yeah. So this is a positive line. Now, if I need to connect it to a positive line, so 2, so only one bit is supposed to be high, that is A, B, C, and D. So only C is supposed to be high. So it is 0010. And for 3, I need C and D should be high. So I will connect it to C and D. So if you are able to see my screen, the 3 line is connected to the C OR gate as well as D OR gate. So all the both the OR gates will give you high when 3 is pressed. Similarly, for 4, only one B gate is supposed to be high, so it will be 0100, and for 5 it should be 101. So 0101 will be there. So 1 and this is 1, and this is supposed to be 0. So the output will be for 5 it is 101 or 0101, right? 4 plus 1. Then for 6 it should be 0110, right? So this and this 4 plus 2 is 6. Similarly, for 7, all the 3 BCD pairs should be high. So 0111 should be the output. And for 8, only A should be high. And for 9, A and D should be high. So only those OR gates are kept high. So as you can see, this is the simplest decimal to BCD encoder which can encode decimal numbers, and these are the keys which are being used on the calculator. So this is a system where we need to study how the calculators also work. So because calculator is supposed to be the digital uh, circuits, right? So this is the basic small basic circuit diagram for which is being used to code the decimal numbers into BCD codes. So as you press the key, a code is generated in the form of binary. So this is called as a decimal to BCD encoder. And similarly, we are having decoders. So again, it is a combinational logic circuit that converts encoded signal back to its original signal. Now, this is a block diagram of the encoder. as you have seen the above circuits, it is 0, 1, 2, 3, 4 up to 9, and it is being converting it into the binary. So this is the circuit for this decimal to BCD encoder, and this is shown in this block. And on the other hand, this ABCD, which is again a BCD code, is now been decoded back to the decimal number. Now this is called as a decoder. So this is the say analysis of an encoder and the decoder circuit. So we can have that. Now for the BCD to decimal decoder, we will be using 4 inputs like this, and you'll be having 10 AND gates, 1, 2, 3, 4 up to 10, as it is shown over there. I guess it is visible to you. And yeah, so only 0, 1, 2, 3, 4 gates are being shown, rest are put on in the dots. Also, the outputs are y0, y1, y2, y3, dot, 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 up to y9. So we will be having 10 AND gates. And as per this codes, A, B, C, D, one of the gate is supposed to be gate enabled, right? So this is how it is being used, right? So yeah, okay. So this is how it is being say made. So depending on the circuit, when A, B, C, D means all the four are 0, 0. So they are being inverted and they are being given to the first gate, right? So if all the four are 0, 0, then the inverted output will become 1, and this gate is supposed to be enabled, and this gate output Y0 will be high, which implies that the binary code 000 is supposed to give you 0 over here. Similarly, and we'll put a LED over here which resembles like 0, so it will show you 0. So this is for 1 0 0 0 1. So this is being directly fed, it is not being given through the inverted output. So this gate is supposed to become high when it will be 0 0 0 1, right? So automatically Y1 output will become high. Similarly, for say 2, only C will become high and the others will remain 0 0. So A, B, C in 0 0 1 0 will be the input, and I expect that the two AND gate number this 2 will be enabled, and the output will be Y2. Similarly, for 3, I guess C and D will remain high. So I'm putting that C and D high to this AND gate, and A and B will remain 0. So Y3 will be the output. And similarly, for say 9, I require 1 0 0 1. So this is 1, and these are both BC are 0 0, and the last B is also 1. So you'll be giving high at this output. So this is how the BCD to decimal decoder can be made. I guess this much is enough for today. Have you understood? Do you have any questions on that? Hello? Am I audible? Vishnu?
Yes,
Yes,
sir.
sir.
Have you understood?
Yes, sir.
कोई
Yes,
problem?
sir.
Yes, sir.
Problem ही
No,
problem. No. Very good.
no.
So I guess we can sum up over here, and we'll continue this in the next lecture, in the next class, hopefully Monday, right? So
Yes,
okay,
Yes,
sir.
one more thing.
yes, sir.
I'm going to take your practical lecture today at say 3 o'clock, and I expect everybody should be present over there. I will just take your attendance. I guess almost all the practicals what I have taught has been completed. So we'll take it as the practicals have been completed. But just to check, we'll have say a practical class at 3 o'clock. So I guess I expect that everybody should be present in the class. I will take your attendance and I will leave. Will it do? Hello, is it
Yes,
okay?
yes,
And
sir.
rest for you, I expect that please. Oh, so please do complete your records, and uh, as the time permits, get it signed or submitted in the department if say colleges are start, right? So I'll sum up over here. Thank you very much for joining. Stay
Thank you,
tuned to my
sir.
YouTube channel. Please go through my YouTube channel, like, share, and subscribe my channel. I'll be sharing more videos of electronics on the same. So by that time, stay home, stay safe, take care. See you in the next lecture. Thank you. Good day. Bye.